In this video, we're going to talk about how to find inverse functions when we're given the function. Okay, so first of all, if you have the function f of x, you can write its inverse as f inverse of x. So this little -1 there will represent that this is an inverse function. And if you're given ordered pairs, like in this problem down here, then in order to find the inverse, you're going to switch the x and the y. Okay. Now, if you're given the inverse of any other function, f of x, or it could be written as g of x, or whatever letter that you want to, you replace the function notation f of x, g of x, whatever, with a y. You switch the x and y, and you solve for y. Okay. So recall that this is true if inverse functions are composed with one another. If you put one function in the other, we did this in a previous video, if you put one function within the other, you're always going to get x as an answer. Okay? Alright, so let's take a look at the first one. We've got two functions here. One of them is discrete and one of them is continuous. So we've got x plus 3 over 5 for g of x. Okay, so in order to find the inverse function here, we're going to replace the g of x with a y. So instead of g of x is equal to x plus 3 over 5, we'll say y is equal to x plus 3 over 5. Okay, and then we're going to switch the x and the y. So x is equal to y plus 3 over 5. And then we're going to solve this thing for y. We need to get y by itself. So I'm going to multiply the 5 to the other side. So that gives me 5x. When I multiply 5 on both sides, it makes that 5 cancel, equals y plus 3. Subtract the 3. So we get y is equal to 5x minus 3. That is going to be the inverse. Okay, so I'll write a little inverse there, and let's write it in the notation that we said earlier, which is we're going to write it like this. So g inverse of x is equal to 5x minus 3. Okay. Now the next question says, what happens if you compose them together? What happens if you put the inverse function inside of the other function? And recall that this is another way of writing this. Okay, so the inverse that we just found, we're going to put inside the g function in place of x. Okay, so that's going to be 5x minus 3 goes right here. So 5x minus 3. And then we write the rest of this, so plus 3 over 5. Okay, so you got your minus 3, your plus 3 there, so that's 5x over 5. Cancel those out, you get x, which you should get x. If they are actually inverses, you will get x. Okay? Alright, so this question says, what is h inverse of -7? Okay, so before we can find h inverse of -7, we need to go ahead and find h inverse. Okay, so h inverse is equal to, now we're going to take a look at all these x's and y's, these ordered pairs, and we're just going to switch them. Okay, so we get, instead of -7, -8, we get -8, -7, and then -7, 0. I'm running out of room, so I'll write it down here. -5, 2. And the last one would be -4, 7. Okay, so there is h inverse. Now it says find h inverse of -7. So we look at these points, and this is the x values now. So now that we found h inverse, we look at the x values until we find a -7. There it is, and we get the corresponding y value that goes with it. So h inverse of -7 is 0. Okay, so in order to find this, we switch the x and the y in order to find h inverse, and then we went and found the x value, -7, and its corresponding y value is 0. Okay, let's do another one. So this one says find g inverse of 1. So the first thing we need to do is find g inverse. Same thing we just did. So we'll write 1, 0 for the first one. 7, 1. -3, 2. And 5, 7. Okay, So G inverse of 1, again, we go find the 1. There it is right here. And we find the corresponding y value. So that gives us 0. Okay. Let's do this one. It says find H inverse of x. Okay, so we will rewrite this as y is equal to this stuff. So y is equal to negative x plus 13 over 11. And then to find the inverse, we switch the x and the y. So it's x is equal to negative y plus 13 over 11. Solve for y, so we multiply through, so that gets us 11x. When I multiply the 11 on both sides, equals negative y plus 13. Okay, and let's go ahead and move the y over here. So that's by addition, so 11x plus y is equal to 13, and then move this one over by subtraction. So y is equal to negative 11x plus 13. So H inverse of x is equal to negative 11x plus 13. Okay, and then the last problem here says compose the two. So put the inverse function into the regular function and then find the value that you get when you plug in a 1. Okay, so the first thing we need to do is find h of h inverse of x, and then after we find that, then we can plug a 1 in. Okay, so if they're inverses, if we did our problem right, this should be equal to x. Okay, so let's make sure that that's true. So here's the inverse, and we'll take this inverse and put it in place of this right here in the original function. So instead of negative x plus 13 on top, we get negative parentheses negative 11x plus 13. Okay, this negative came from here. This negative was because of this. Okay, and then plus 13 over 11. So distribute the negative, so you get positive 11x minus 13 plus 13 over 11. These two cancel, so you get 11x over 11. Those two cancel, you get x. Okay, so this is equal to x, which is what we assumed it would be if we did our work right. Okay, now if you plug in a 1, well, you just plug in a 1 here. Everywhere you see an x, you plug in a 1. So if you plug in a 1 right here, you get 1 as an answer. And that's it.